All right, welcome everybody to week 5, day 1. Today we are going to be talking exclusively about the RTX On assignment. Basically, what I've given you is what's called a greenfield assignment. You're given essentially a blank main.cc, and it is your job to build a complicated project from scratch. Okay? This assignment is technically a data structure assignment. The data structure that we are implementing in this assignment is called a BVH, Bounding Volume Hierarchy, and it is used extensively in 3D graphics, computer graphics, various spatial algorithms, and things like that. It's not a standard data structure in the core curriculum. You won't find a BVH in there anywhere. You will find trees and some other stuff, and this is kind of a form of a tree, but it's kind of its own thing that has a huge number of uses. Really, though, the point of this assignment is to get you using the concepts and skills we've been practicing for the past 3 weeks. Making a class, proper class design, making a header file, making implementation files, making a make file to build the whole thing together, thinking about which classes you need. You need a array class and a point class and a rectangle class, and how do those fit together? Should a rectangle know about a point? Maybe. Should a point know about a rectangle? Maybe. I don't know. One of the hardest things in object-oriented programming is deciding who knows about what, right? And so in my class, the way I did it, the rectangle knows about the point because its two corners are both points. So I have a minimum point and a maximum point, and so it has to know about the point class because it uses it. And that also allows me to fairly reasonably implement an is-in member function that takes a point and it returns true if that point is inside of the rectangle. So let's take a look at Dumore's assignment. And so inside of here we have a very extensive README. It is 280 lines long. I was up late last night, not only doing the implementation myself, but also writing a extensive README file for y'all because there's not a whole lot in the main.cc. If you look at the main.cc, that's what you got. Good luck. Have fun. And I did give you one line of code because this is not something you would probably figured out on your own. So there's a program called Figlet. Figlet banner prints something, so I wanted this program to start with a cool little RTX On banner like that, and colors. The 1,800 words. Yeah. I wrote an extensive README file for y'all. You can even spell out the words. What do you mean? RTX. I don't know. What do you mean by couldn't spell the words? So. So that I kind of did for you. There's the thing and there's the thing. Good luck, have fun. Oh yeah. Well, yeah. GLHF, right? Okay. So you might be wondering though about this little bit here, and so if you don't have that, let me show you what happens. G plus absolutely nothing happens. On mine, interesting. Yeah, on mine it warns. It's fascinating that it doesn't do that. I wonder. No, it's supposed to warn. I don't want to show you my code. But yeah, it warns that you're not using the result of system. So let me explain what system is. System is it's a function that runs a program. So if you were to do something like, let me put this back in here. If you were to do something like system ls pipe through lolcat, something like that, then when you compile the code and run it, you'll see that it does an ls command and it pipes the result through lolcat. So it's literally running a program from inside of your program. So if you want to have you know, just launch a program to do something really fast, you can do it that way. It's not considered great practice, you know, per se, but you can do it if you want. And so here we have it doing ls 5 through lolcat, right? That's what it's doing. And so system returns an integer, and the integer is if an error occurred or not. So the function is flagged as no discard, and which means you're supposed to trap the return value and use it. For whatever reason, it's not yelling at us here. It's kind of interesting, but yeah, normally it'll print a warning. It's not an error; it's just a warning saying, "Hey, this thing's returning a return value, and it's supposed to be really important because it's marked as no discard, and you're not doing anything with it. So we're going to throw out a warning for you." And it's kind of annoying. So this is how you deal with it. You not it, so you do something with it, and then you cast it to void, which means it goes away. It goes into bye-bye land. And so if you do this, it turns off the warning. There's a pragma. Pragma means compiler directive. It's not standard C++ or anything like that. This is specifically a GNU compiler collection, pragma, that turns off the unused result warning. And if you do that, then it will shut up as well. But the trouble with doing this is it'll turn it off for all warnings of that nature down below, and I only want to turn it off for just this one. And so if you want to do it even more properly, you would push the current stack of ignored results, and then do this, and then call the function, then pop. It's way too much effort. This is just way easier. So, and that also, the pragma only works for GCC. It doesn't work for Clang, I believe. So. All right, so that is what I give you, and you can make of that what you will. All of you have to have partners. Does anybody not have a partner currently? If you do not have a partner by the end of class today, one will be assigned to you. And yes, you do have to work with them. So, anybody looking for a group, just post LFG in the chat, and we will partner you up. We'll be doing a lot of lab time today. I want you guys working on this. Now, this assignment is structured in such a way that I made it deliberately, I don't know what the right word is, forgiving. Like, if you don't complete, like, for a lot of the homework assignments, like, if you don't complete at least, like, most of it, you get, like, 0 points, right? Because, like, your code either doesn't compile or it doesn't, you know, load the data, like, the data you need at all, and you just kind of potato and you get a 0. I don't want anyone getting a 0 on this assignment. There's very close to no excuse to getting a 0 on this assignment, because some of the things I made were like really easy. And so some of the things are hard and some of the things are easy. And so I sort of structured, you have a partner but he's not responding, then I'll partner you up with Jimenez instead. Well, AFK people get booted from groups. That's just how it works. So basically, the first couple points are like pretty easy. Like if you took CSI 40 and you have been paying attention in this class, you can make a rectangle class, and you can make a vector of rectangles, and you can load into it from a file. That's the first couple points. Read from a file into a vector of rectangles, read from a file into a vector of shots, arrays. Okay. So you need to make a rectangle class, you need to make an array class. Array is a point and a line, as slope. And you probably need to make a point class too that holds just an X and Y location. You do that, you can get some points. You're not going to get a lot of points, but you're going to get some points. Okay. You make your own files to load. I give you some. So I gave you a couple sample map files, a couple sample shots files. It's got some. It's got the file format. That's the important thing, right? You need to follow the file format because that's part of the assignment. So, yeah. So step 1 is you just kind of like launch it and read from a map file, and then just print the vector that you load to the screen. Points, easy points. Do the same thing for shots, easy points. Next up, let me just open up the README file. Yeah. So the first thing you do, just load the map and then print it to the screen. Second thing, load the map of shots, print it to the screen. Third thing, map check. Okay, so this starts getting a little more interesting. And by the way, I structured this so that the kind of stuff you're doing is actually kind of, it's actually kind of accurate, like the kind of thing that you would do if you're doing computational geometry or you're doing working for a video game company. They do map checks all the time to make sure that there's no problems with the map. If you were to make a map for Quake and you left an opening to the outside world, not surrounded by a skybox or anything, it just doesn't draw there ever. And so as you move around, you get this weird like psychedelic effect as like whatever was in the frame buffer there before, it just doesn't overdraw that point, and it looks really, really bad. And so they do like a map check that like makes sure that the whole map is enclosed in a convex hole that bounds the whole thing. For this one, it's kind of the same idea, actually, come to think of it. So for this one, you have to make sure that remember what you're doing is you're doing rectangles inside of rectangles, right? And the reason why we do this is because if you have 3 small rectangles and 1 big rectangle wrapping around it, if you draw a line and the line misses it, the line goes this way and the rectangle's up here, then if it misses the big rectangle, it misses all of the smaller rectangles, and you can not have to check all of those. You only have to check the big rectangle. Now, this doesn't work if any of the smaller rectangles are outside of it or if they stick out. And so what the map check does is you just make sure that all of the corners of all of the rectangles inside of the rectangle, a bigger rectangle, are inside of it. That's it. So you probably need to make some sort of like is-in function that takes a point, and the rectangle will return true if that point is inside of the rectangle. You just do that for each of the corners, for each of the rectangles inside of you, and if they're all within, you say cool, and if it's not, you say fail, right? So you either say map correct if it checks out for the whole map, or you say map error box 1, whichever. Whenever you encounter an error, you just immediately print error, quit, and that's it. And this is actually something that real life people do in real life. Like you'll write utilities to verify that your stuff isn't broken, and we typically do this because, like especially in video games, you don't want to have to be constantly verifying this data. Like if you're in the game running around, you don't have time to be doing all these like expensive map checks to make sure they're all there. You have to just kind of assume that it works for speed reasons, but you still need to check it at some point because the map maker might screw up. And so having like a tool that does the map check, so every time you get like a new map, you run the tool on it and verify it, and then you bring it in, and then the game will just assume that everything's good and it doesn't have to do these expensive checks at runtime. So that's a fun little assignment. Shouldn't be too bad. After you've got your point class and your rectangle class, you should be able to do that reasonably easy. Like here we've got the outer rectangle goes from 1010 to 2020, and then the inner rectangle goes from 1515 to 2525. Yeah, there we go. It's mirrored. And so part of the inner rectangle is sticking out. So, bad. Map error, box 1. Remember, the first box is box 0. The next box is box 1. And the file format means this is a non-solid rectangle. It goes from x10, y10 to x20, y20, and it includes within itself a rectangle at index number 1, or line number 1. And so here we are at line number 1, and this one goes from x15, y15 to x25, y25, so it's sticking out. It's bigger. This point, 1515 is inside, but 2525 is sticking out. A valid map cannot have any overlapping boxes. That's not true. It just means that if you enclose a box, like if box 0 here encloses box 1, no part of box 1 could be sticking out. It is overlapping. Like you have a parent box and you have the child box. They overlap each other, right? Like they literally overlap. They just can't stick out. So, and then for solid boxes, they can overlap as well. So that's very common when you're doing maps. You have a a wall and then you just push another wall through it like this. And then from the inside, you just see the corner. But if you looked at the map from the outside, you'd see that the map maker just went, that's good enough. There you go. And so solid blocks overlap all the time. Solid box means the ray stops if it hits the box. That is correct. Yeah, array does not hit a non-solid box. I mean, overlapping shall not contain. That's correct. Mr. Shook. Okay, next thing you need to do is rectangle, rectangle intersection. This is not too bad either. So I would expect, even if your computer science skills are not like super elite, you should be able to at least get through number 4. Start early. If you're not great at doing I/O kind of stuff, there's a little twist here with the very first step, which is that you need to be able to load this file format here, and the file format again is not solid, x0, y0, x100, y100, and then if it's a non-solid rectangle, there's one line per box. If it's a non-solid rectangle, it takes an arbitrary number of children. So it could take 2, like that. And so a lot of students don't know how to do that. And so if you don't know how to do that, then ask in the help channel and help will be provided. Each student has the right to request a code snippet from me once during this project. You must send me a meme that says Gondor calls for aid. The beacons are lit. And then I will give you a code snippet to help you out. More than just like, hey, here's how you do this. I will actually give you a little bit of code to help you on your way. You get one help per person per project. Okay, so coming back to where we were here. Where were we? Operation. Everybody gets one. Map check. Right, here we are. Rectangle, rectangle intersection. So rectangle, rectangle intersection is not too bad. And so basically you just have to return true or false if 2 rectangles overlap each other. If they overlap at all, including just touching, then you return true. You don't have to say where they overlap. You don't have to come up with the area of overlap. No. All you have to do is just return true or false. Do they touch each other or overlap in any way? That's it. So if you have a rectangle that goes from 0, 0 to 10, 10, and you have one that goes from 9, 9 to 10.1, 10.1, they overlap, right? There's a 0.1 square bit of rectangle where they intersect. Okay, and then this one goes from neg 10, neg 5, neg 10, neg 10, neg 5, neg 5, and then this one's up a little bit from there, so they don't touch all. So you either output the intersect or you output they don't intersect. And so everybody should be able to do this, especially because you're working in groups and things like that. How you divide your labor up is, of course, an interesting question. You can have one person working on the ray class and one person working on the rectangle class. Wait, for that grid, is it just like a really thick array? What do you mean? What grid? It's these are doubles, by the way. They're not ints. They're doubles. Now, this is the one that it starts getting a little spicy. Okay, so you have a ray, you have a point, you have a slope, and you have a rectangle. Does the ray hit the rectangle? And this is, by the way, none of this stuff in 4 or 5 use the map data. They don't use the map data. You just manually enter a rectangle, and it tells you do they touch. For this one, you just manually enter a ray and a rectangle, and it tells you if they touch. That's it. So does a line intersect a rectangle? And if it does, what point? Okay. So here we have a rectangle that is at x is equal to 5, y is equal to 1, x is equal to 6, y is equal to 100. So it's 1 unit wide and 100 units tall. Okay. 99 units tall. So it's like a very thin wall sticking up at x is equal to 5. So if we have web browser. There we go. Alright, so what do we say? Okay, no. Can I edit you? 5.1 to 6.100. No? How do we make a rectangle from these ones? I don't even know. No, let's just do it 6 to 10 so it appears on the map a little better. Okay, so let's say we've got let's make it a little taller, whatever. Okay, so this is the minimum point, and this is the maximum point. Okay. All these operations can be done in main. I would say no. I would say if you're doing object-oriented programming correctly, you're probably going to be having the brains of the operation be in a .cc file somewhere else. So for example, the rectangle class should know if it intersects another rectangle. It's not really main's job to know that, right? Main is just the directory. You pick an option, option 4. Okay, go enter a rectangle and a rectangle, then you call, does this rectangle intersect another rectangle? But the brains of the operation are over in rectangle.cc or something like that. Yep. So anyway, so here we got a rectangle. I don't know how to draw a. Just fire up. I've lost my. Oh no, I found it. Look at that. I actually went to Best Buy to see if I can get a replacement Wacom tablet. And here it is. It was wedged underneath my computer somehow. Okay. What is lost has been found. The prodigal Wacom tablet pen returns. Excellent. Okay. Alright, so if we... Can I draw you? No? Are you not plugged in? This is not good. There we go. Alright, so let's insert, let's draw a shape called a rectangle. There we go. And let's also enter a line. There's the x-axis. There's the y-axis. And you are at, let's say, 5, comma, I don't know, 3. Let's say that's like 5 right there. That's like 3. And then this is over at 6. That's at like 15 or something like that. So there's 2 points that define a rectangle. There's min and there's max. Right? And we want to find out if a ray hits the rectangle. Will we always be shooting the ray from the origin? Not at all. A ray has a point. So we could be having a point up here and shooting it downwards this way. And then you will have to return that point right there. Let's do an example from the origin to make things simple. Okay. So if we have a line with a slope of 2, this y is equal to mx plus b. The y-intercept here is 0. Keep things simple. Y is equal to 2 times x. Now, here's how you do line rectangle intersection. So how far away is the left edge of this rectangle from the origin? Horizontally speaking. 5. So how far up does this line go when x is equal to 5? 10, right? So this spot right here is 5, comma 10. So we know this spot is on the rectangle because we picked the x min, right? So that we know that the x is in the range because we picked it. Now we have to see, is 10 between 15 and 3? Yes or no? Is the number we get here, is this between 3 and 15? Yep, so it's a hit. And the hit location is 5 across, 10 up. Easy. Alright. So that's how you do that. Now, what about the bottom edge here? Let's say that you're shooting a ray like this. You're gonna hit the bottom ray. Well, in that case, you can't use, well, you would probably check x min, right, first. And then if that misses, then you have to check y min. So y min in this case is 3, right? So you would do the same equation, but this time you would, see here we put in x min, right? Not the superheroes. But x min, 5. Okay. And then we check to see if the result we got was between 3 and 15. Now we're going to do it for y min, which is the off-brand x min. It's got all the heroes that aren't Wolverine in it. So, it's like DC Comics. They suck. Okay. So, okay. So now we're going to use the y min, right? Here. And, are you a DC Comic fan, Mitchell? You use y min here? No? Okay. Equals 2x. All right. And so the place where we hit, so where y is equal to 3, we hit x is equal to what? Yeah, they're not all bad. I've read some good ones. X is equal to 3/2, right? So when y is equal to 3, x is equal to 3/2, which is like over here. Okay. So it's actually, let's see, not really to scale forth 3. Yeah, it's more or less okay. Yeah. So when the line crosses y min of 3, x here is going to be equal to 3/2. So 3/2 is to the left of x min, right? So it's not between 3 and 6, so it misses. We got to miss over here. And that's all you really have to do. So you just substitute in one edge of the rectangle and then see if the result you get is between the minimum and maximum of the other axis. So you substitute in y min and see if you got an answer between x min and x max. For this one, you substitute in x min and see if you get a result between Magneto, between x min and x max. Okay? But you have to determine what side the ray is coming from. Or do you? I don't know. Probably. Or not. Or you can do all 4 if you want. You can do x min, x max, y min, y max. But then you might get 2 hits, right? And then you can see which one is closer if you want to do it that way. I didn't do it that way. I only do 2 checks. Because if the ray's down here, it can only hit the left side or the bottom side. It can't hit the other sides. Okay. So, yeah. So if you check against all 4 sides, just be aware that any line that hits is going to hit twice, right? Unless it's exactly like on a corner or something. I don't know. And you get like a rounding error or something. So yeah, so that's how you do line and rectangle intersection. You just plug in x min for y equals mx plus b. You plug in x min and you see if the y you get is between y min and y max. And then you do the same for x max. Plug it in, see if the result you get is between y min and y max. Then you do the same for y min and see if the x you get is between x min and x max. And you do the same for y max and see if the x you get is between x min and x max. And if you do all 4 checks, then you are going to get 2 hits, and you have to see which one is closer to the origin of the ray, that's the hit location. I didn't do it that way. I only do 2 checks because I know which direction the ray is coming from. And so I only check the 2 closest to me. So my code's a little bit more complicated than perhaps it needs to be. Who was asking if, was it Odal? Yeah. Will you always be shooting the ray from the origin? No. So what if we were shooting from like here instead? Same line equation, except it's now going to be y is equal to 2x plus 3. What I did, and you don't have to do it this way, is I just moved everything down 3 units. So I just, whatever the origin of the ray is, I just move the rectangle by that amount, and I move the origin of the ray by that amount. It just makes the math a little bit easier. And then when I'm done, I put it back. So what I do is, you don't have to do it this way. The equation works just fine the original way. It just kind of made my lines of code a little bit more readable, I think, maybe. I'm not sure. So like if our origin was x is equal to 0, y is equal to 3, what I did was I subtracted 0, 3 from these 2 points here. And I ended up getting, what is it, 5, 0, right? Because you see that, how it's kind of like on the x-axis now. Like if this is the new x-axis here, then this is basically 5, 0. And then this guy would be kind of like 12 up instead of 15 up, like that. And then you can just sort of neglect the plus b. And then it's just very simple. Y is equal to mx, or x is equal to y divided by m. Makes the math a little simpler. By just shifting, like whatever the x and y value is for the origin, you just subtract that from the min and from the max. You essentially shift the entire coordinate system so that the ray is always on the origin, and then it just becomes a very simple equation, y is equal to mx. And you substitute in x min, see if the y you get is between y min and y max. Substitute in x max, see if the result, you don't have to do that. It's just a way of simplifying things. And so, like, does this one hit? Let's find out. So y is equal to 2x. So this one's 5 across, 10 up. So yes, it will hit. It'll hit right here, in fact. It'll hit at 5, 10 in the new coordinate system. And so when you're done, you have to put it back. So you moved everything down by 3. So in order to return the actual coordinate, you have to put the 3 back in. And so you're like, got to hit at 5, 10. So then you actually return 5, 13. Because you shifted everything down by 3, you did the intersection test, hit. And then you shift everything back up by 3. So if you subtracted this out at the beginning, you put it back at the end. Or you can just ignore that and do it with a plus b and have a little bit more algebra. It's up to you. So, yeah. That is ray rectangle intersection. Any questions about it? My code's not small for it, by the way, either. Like, it's not a terribly small function. I just special case vertical lines, for example. Horizontal lines and vertical lines are both special case. That was kind of annoying. Let's see it. I just gave you the answer. So you don't have to worry about the top side and right side. Not if it is in the first quadrant. So if after you shift everything down so that the ray, let's say, let me give you another example here. So let's say that you're here at like 4, 1. Then what happens is the so let's say you're shooting a ray up from 4, 1 like this. So what I do is I translate down 5, 3 to be 1, 2, and this would be at what was it originally? 6, 15. So I'd subtract out 4, 1, and this one would move down to 2, 14. And then I'm like, okay, this is in quadrant 1. Do you guys remember that from algebra? It's like 4 quadrants. intravenous. So if the rectangle, so if you have a rectangle here and the ray is over here, then this is quadrant 2. So what I do is I move, wherever this thing is, I move it so that it is the center of the coordinate system. And then I only have to check this and this. So I look at which quadrant the rectangle is in. Okay. Bit of an optimization. If it's in both, then you only have to hit 1, I think. Yeah. You only have to check the left side. If it's in all 4, you're inside of it. Bit of an optimization. You don't have to do it. Will we take a hit for compiling time? No, compiling time is not ever graded in this class. If you mean runtime, yes, the 10th point will be involving large numbers of rectangles and stuff. What do you think the hardest part is going to be? This function, probably. Once you get this, then you're basically in the home stretch. So, and I don't even think it's that hard. Like the algebra to do, there's just some, you have to special case horizontal lines and vertical lines, and you have to make sure you don't do your math backwards and things like that. It's not too bad. Once you got that done, you're in the home stretch. Okay, and so none of the rectangles can be crooked. All of them are axis aligned. All of them will have. The top and bottom will be parallel to the x-axis, and the left and right sides will always be parallel to the y-axis. And that's because we're doing something called AABBs, which is axis aligned bounding box, AABB. And we use AABBs because it makes the math easy. That's why we do it. So, how do you handle it if the rays start at 0? Then you just subtract 0, 0 from the minimum and the maximum. Hey, it's simple. Next assignment, we use rhombi. We could. We can do arbitrary polygons. Would that be fun? Then we'd have to have ray line segment intersection. So given a line segment, does the ray cross it? You could do that with a little bit of linear algebra. It's not too bad. It's actually maybe about 10-ish lines of code, 10 to 20 lines of code, depending on how you implement it. Not too bad. Polygons, 2D kinematics, in-phase variable shapes in an n-dimensional coordinate system. Oh, man. Yeah, it gets annoying when you have n dimensions. Like, everything just gets like dumb. Like it gets really dumb. Okay. Integral calculator. I did that a lot. When I took my programming languages class, the go-to implementation was, oh, you've learned a new programming language? Implement integrals in it. You know, so you take a equation, a minimum and a maximum, you integrate it between that range, you output a number. And if you can do that, they figure, all right, you know that language. And so when I took my programming languages class, it was literally a new programming language every week for 10 weeks. Every week you learned a new language and you would implement integrals in it or something on that level of complexity. Riemann sums, whatever. Does the STL have a linear algebra library? Not yet. They've been dithering on that for a while. It's supposedly coming. Like it's a known weakness in the standard library, and supposedly they're finally going to have matrices and linear algebra and stuff like that in it, because literally everybody who does this kind of stuff implements their own vector class, vector 2D class, and matrix class and things like that, and do dot products and cross products and all that stuff. So, okay. Ray. So in I think the previous class, I don't know if it was in the online section, but in the in-person section, I joked that ray tracing was invented by a guy named Ray. As it turns out, one of the earliest ray tracing algorithms was actually called the Reyes algorithm. So, not named after a person named Reyes, done by Pixar, but it was actually named after Point Reyes, which is where they were based out of. Beautiful area. I wouldn't want to have my house there, though. Man, this looks ready to crumble at any time. So, yeah, LucasArts used to make a lot of money doing 3D graphics for people. So, the people that did Star Wars and things like that, they also did. I had a friend that worked for them, and they did a lot of like 3D animation for just like commercials and things like that. Like they did a lot. They did a lot of stuff, and they're based out of Marin County, stuff like that. So Pixar, which was kind of part of that whole thing, who made Toy Story and what was the most recent one? The one about the emotions and things like that. Raymond Tracington. Yeah. Yeah, they named it the Reyes algorithm. It's ray tracing, but it's named after Point Reyes. Inside Out, that's the one. Yeah, thanks. Part of Disney now. Everything's part of Disney now. It's because those people have no integrity. If Disney offered me $1 billion to sell out to them, I wouldn't take it. I dare you, Disney. I dare you. Compromise my integrity. I dare you. Alright. So, yeah. So once you get ray, rectangle, intersection going, then you're in the home stretch. Okay? And so, after that, you're just going to use what you've already done, but for a vector. And so, for operation 6, what you do is for every rectangle on the map, you see if it is intersecting another rectangle on the map. Solid rectangles only. And so this is how collision detection works. If you have a physics engine and things are flying around and bouncing into each other, you need to be able to very quickly say, oh, these two things touched, and you do physics, bouncy, whatever, or you call a call back saying, hey, your rocket launcher rocket just hit a wall, and then the code's like, oh, I need to explode then, and it blows up and stuff like that. So that's how kind of a game engine works. When you have things moving around, when you hit something in a world, you have to be able to very quickly tell that two solid things are touching now, and or about to touch. Like you might have the rocket, and it checks to see, hey, is that point in front of me where I'm about to move to, is that solid? And it's like yes, and then it blows up. So, so this is like how game engines work and stuff. So, so what you're going to do is you're just going to use that function you wrote earlier to see if two rectangles overlap, to do that with all the rectangles. So that's it. So you have a vector of rectangles, you just run that function on every pair, essentially. And you only print out one of the, like if 1 and 5 intersect, you don't print out 5 and 1 intersect. You print out 1 and 5 intersect. So whichever one is lower, you print that one first. Whichever one's higher, you print that one second. You print it once. Okay. Disney monopolizing movie productions, Microsoft monopolizing video games, Amazon monopolizing the market. Was it Sony that just bought out somebody, Bungie or something? Yeah, there's been a lot of acquisitions recently. Time to show you some integrity. Yeah. Yeah, Blizzard got bought out by Microsoft. Yeah. How do you take into account rebounding from elastic collisions? Well, it's a bit off topic, but sure. If energy's lost, not lost, it doesn't matter too much. So let's say you have a wall. And this wall is static, just to make things simple. Static objects don't have physics run on them. It saves time, right? Every moving object has like a velocity, right? And so every frame, they're going to move forward in that direction, right? As they move forward, this is like over time here, right? And so every dynamic object, this is a dynamic object here. Every dynamic object, every frame has to have its displacement vector or its position will move based on the velocity, right? So its position will update based on the velocity. So if a second has gone by and has a velocity of 10, it's moved 10 in whatever direction the velocity is pointing. So static objects save on your processor, right? So because you don't need to move them, you don't need to run physics on them. They don't collide with things, right? Things collide into them, but they don't collide with things. So so let's say the box hits here. Oops, that was my eraser tool. So let's say it flies in and it hits here. Okay, so you now have a box that is collided with a wall, and you want it to be like an elastic collision or something like that. Cool. So its velocity is moving this way right now, right? You want it to move this way. And you do so by, this is called a normal vector. Whatever theta you have coming in, the angle between here, and it's not exactly to scale, whatever, is going to be the angle coming off. And then the box will kind of fly off and it'll come in, boom. I think it needs to be actually down a little bit, whatever. Yeah, it doesn't matter. So you get the idea though? So the theta of the angle of the velocity to the normal vector is the perpendicular vector. So whatever, like if this is the plane, this is the normal vector. So wherever the plane is, it's got a normal vector, and you reflect around the normal vector. So basically, you do that, and that's a little bit of linear algebra to do reflection. And essentially, you can just kind of rotate it twice if you want. Rotate it this way, rotate it that way, done. Or negative, this was a negative, it's like -1. Yeah, there's different ways of doing it. Okay. So that's how you do collisions. And if you want it to be like not conserving kinetic energy, you can just have a lesser velocity coming off, so it doesn't bounce fully. And you release the remaining energy as heat. No, nobody does. Nobody cares. Yep. So that's that. And so basically, if you had your BVH, this would be like a static thing. This would be moving. And then when you report an overlap, then you call some function to handle collision. And so if it's just your standard like bouncy ball or something like that, then it will just reflect around, comes in, boop, and it bounces off in the opposite direction. It's like you take the vector, the negative of the vector. This is, let's see. It's like, no, you just add the normal vector twice, maybe? Yeah, I think that's it. You scale it to that size, yeah. And so it's the original, let's see, V1, okay. Yeah, so V2 is equal to V1 plus the normal vector times 2, something like that. And the normal vector has to be scaled to be the same size, I think. So that, yeah, once, yeah, twice. I think that's right. Okay, something. Okay. There's different ways of doing it. You can do a rotation to do it as well. Yeah, anyway. So this is the kind of stuff you learn about in IS 50B. 50A, we don't get into this kind of details. 50A is a very accessible class for the novice who's got light programming experience. Okay, so yeah, so basically this thing, you're just going to be calling your function earlier that you said do two things overlap. Yeah, okay, cool. Just do that for all of them. Easy. So for a vector of rectangles, just call it on every pair of combinations. And then for the last one, it's the same as option 5. So if you have option 5 done, then option 7 is pretty easy also. So basically for every shot in the shots file, you see which box they hit, and that's a ray rectangle intersection. And but this is going to be a little bit more tricky because now you've got to traverse the BVH tree. So if it hits a big rectangle, then you have to check all the kids inside of it. So this last one here is the only one that I would consider actually hard. All the other ones are like pretty straightforward. But basically, it's even this is going to mostly just be using your ray rectangle intersection. And if you had to really brute force it, you can just say, for this ray, see all of the rectangle, go through every rectangle in the vector, write down everybody you hit, and pick the closest one. Like if you just had to get that point, you can do that. You're not going to get the speed point, the 10th point, but it'll work. So just for array, go through every rectangle, see which one we hit, pick the closest one. It's definitely the hardest one to do, though. And then if you want to make it fast, you actually have to do the BVH tree traversal, where you go inside of a rectangle and go inside of a rectangle, and look at all the kids, see which one to hit. Okay, that's the closest one. Okay. It is due next Monday, so you will have a total of 10 days to do this assignment. You got a partner. If you don't have a partner, one will be given to you by the end of class. So I want all of you to start working on the assignment. There is a hints file inside of the RTX On directory. There's a hints file that kind of has some ideas on how you might want to do things. Invariants, I didn't talk about what invariants there are. Can the minimum value of a rectangle be bigger than the maximum? Probably not. Die in that case. So you start working on it Sunday night. Lord, yeah, it's I have to tell you, when it's the night before it's due and a student's like, wait, how do I build this assignment again? That means you haven't compiled it yet all week, and it's just oh, this is not going to go well. This is not an assignment you want to wait to the last minute on. And in fact, if your partner AFKs you, then I will take you out of, if you go idle, I will take you out of a group and put you with another AFK person. So, be active, even if you can't work on it today or tomorrow, just communicate with your partner. Part of this assignment is learning those social skills on how to collaborate with other programmers, because that's really, really huge in computer science. Get a GitHub repo set up, or other means of sharing your code with them. Figure out how to divide the labor up. Who does this class? Who does that class? Who does this function? Okay. Monday morning. Lord, you guys are killing me. For the last one, there was 30 people online at midnight before it was due. It's just yeah, and I'll be seeing some zeros tomorrow, So, all right, go ahead and work on it, and I'll hang out and watch you guys for the next 20 minutes or so. And again, if you need a group, I'm going to scroll up. I think I saw a few people that need a group, so I will start moving things around. I'll message you if I group you. Okay, but I'm going to stop the recording now. Okay. Good luck and have fun.